little revamp of what we did there. So some of us can type in log 2 of 6 into our calculator. Some of us can't and would have to type log 6 divided by log 2. Why can we do that? Well, I let x equal log 2 of 6. I changed it by definition to log form. And then here, this step, I could take the log of both sides. Technically, all of you have a scientific calculator. You have not only the log button, but you also on your calculator have the natural log button. So I'm like, really? Could I have done the natural log of both sides? Well, I'm going to just change color here. And instead of taking from this step the log of both sides, I'm going to take the natural log of both sides. I'm just curious if this is going to work. Still have my same, a natural log is just a log with a different base. It's a base e. So all of your log laws are still true with natural logs as they would be with logs. So I can bring this x out in front. And I can get x by itself, opposite of multiplying is dividing. And I get x as a natural log of 6 divided by natural log of 2. I am curious. I'm going to take out my calculator. Right? I figured out log 2 of 6. I did log 6 divided by log 2. I'm going to do natural log of 6 divided by the natural log of 2. And sure enough, I get the exact same answer. Fascinating. This is called something called the change of base theorem. It is at the top of your next page on page 402. They've got it explained at the bottom of page 401. But the idea is, and this formula is not, I have it up on the wall, but it is not on your formula sheet. The idea is that you can take, and I color coded it here, which I find really helpful. You can take any log with any base and change it to a new log with a different base. What we did in our previous example, here we changed it in, right? Common log, we picked 10. Natural log in purple, that's like having a base e there. But the change of base theorem says you can change it to any base that you want. It's a really interesting formula because on the left side you see that you have the green B and the purple X. And on the right side you have the purple X and the green B. But the orange A only occurs on the right side. Meaning you can make it any number you want. I'm going to go back to my calculator. I do not recommend this. But have a look. Log 2 of 6. Apparently, I can change this to log base anything. 1, 2, 3, 4, 5, 6 of 6. This might hurt my calculator a little bit, actually. I wonder if it's going to get mad at me. Because I'm going to make my calculator do some very difficult math right now. I changed the base to 1, 2, 3, 4, 5, 6. Of log base 6 divided by log base 2. I am right now in a moment where I don't know what's going to happen. My calculator might cry and crash on me. Because this is really hard math for it. It's going to, in its head, try to figure out what exponent would I need for 123,456 to get an answer of 6? And then it's going to do the same thing with 2, and it's going to put them together. Does it crash? No! It gave the exact same answer. Because I just did this idea. I could put anything for A that I wanted. I was really scared it would crash. All right. Go big or go home. That's right. We could go bigger. we could see when it crashes.
Yeah.
No, I tried that once in a class. I can't even tell you what happened. It was disastrous. I can tell Mr. Speaky afterwards, but you guys, that's where you learn from teaching. Sometimes you do something once and you realize, oh my, I cannot do that again. Because we're not supposed to be teaching classes to that extent. Like, you just use your imagination and it's probably far worse. Just right. There are certain numbers you can't use in math class. And yeah, that's all I'm gonna say. Right? There's certain things you can't. Here we go. Gotta turn this on mute. Like nothing ever happened. There we go. So if you had something like log base 3, you could change that to log 7 over log 3, which would be helpful because you could type it into any calculator. You could change it to natural log 7 over natural log of 3. Also very helpful because you could type it into any calculator. Any other base you could do, but it would not necessarily be helpful. So we sometimes get questions like this. Combine as a single log. Oh, I'm still on mute. Thank you there. I was double protected there for a while. Mic on mute, video paused, everything was good. Thank you. So your change of base, here we could change log 3 to 7. Base of 10 is useful, base of E is useful. Other bases possible to do, but not necessarily useful. You gotta be careful though with the change of base because this is the change of base theorem. It is not subtracting. Dividing a log divided by a log doesn't match your other log law. Your other log law is dividing inside the logarithm. Now you're dividing two logs. But that is the right-hand side of the change of base theorem. So I could change it to the left-hand side and combine those to get a single logarithm. Yeah, now you don't get to hear this story just for yourself because everybody, well, didn't quite get to the end. Didn't. Right. There's still a little bit of curiosity left there.
That's what writing a precision test right after this side.
Oh, yes. All right, we do have 2 minutes. We have time for example number 1. Approximate the value to the nearest thousand. So this is really, this and this to me don't make sense because you need a calculator. And an approximation, usually I think of doing something without a calculator. They do mean here to use a calculator. So what we need to do is use our change of base theorem and say log 5 of 50 I can write as log 50 over log 5. And for me personally, this I can type in quicker even though I have the base of 5 in my calculator. I can do it. I still find typing this in quicker. Or I could do the natural log of 50 divided by the natural log of 5. And since we're short of time, I know you could type that into your calculator and I know that you could round to the nearest thousand. Okay, so this one too, this will be log of 6 divided by log of 8 for part B, or you could use the natural log of 6 divided by the natural log of 8. Both of those would be easy to do. So you can circle questions 3, 4, and 5. Oh, we have a minute left.